Hi folks, this is Şefik. Do you enjoy dark beers? I enjoy a lot. Here, Guinness is a tasty dark stout beer. But today, we are not going to talk about this dark beer. Guinness Brewery contributed a fundamental tool in science and statistics. And in this video, we are going to mention students' t-test, which is an important examination technique to find out an idea from small samples of series. But before we begin, please like the video, do not forget to subscribe to the channel and click the bell icon to get new video updates. Please also mention your ideas for existing and expected videos in the comments. Formerly, brewers have been assessing the quality of beers with some subjective techniques, such as appearance, color, and scent of hops. Sealy Gosset was a scientist in the Guinness brewery and he invented the t-test. This testing technique handles quality control with small samples. In that way, he could examine barleys in the beer brewing process. Thereafter, publishing papers was not allowed by the Guinness authority, so he published this technique in early 19th under the anonymous name student. That's why this technique is still called as student's t-test. Similar to its original usage, we are going to apply t-test for a beer dataset, which is available at this URL. So I'm going to import that dataset with pandas library first. Beers data frame is going to be pandas.read CSV, and here I'm going to read beers.csv. Let's look at the data frame first. International Bitterness Unit, or shortly IBU, measures the bitterness of a beer. I'm going to discard records with no IBU score. That's why here beers data frame is going to be beers data frame, and here I'm going to get its IBU score, check its none, and discard them with the symbol. Now let's check the unique styles of beers. I'm going to call beer get its style column and call unique function. We can convert this numpy array to a Python list. There are tens of beer styles. For example, there are German Pilsner, American Pilsner, and Czech Pilsner. Get this as a first type. Secondly, let's get American Pale Ale. This is going to be label 1 and this is going to be label 2. I don't have to print the unique style of beers. Suppose that I'm going to drink 10 beers for Czech Pilsner and 10 beers for American Pale Ale, and I'm going to compare their bitterness score. The question is that, is there a difference on the bitterness scores between those two samples? Let's get the first sample. Sample 1 is going to be get beers and get beers style is equal to label 1. This is going to return just Czech Pilsner beers and get randomly 10 samples and set random state value to a constant value. Similarly, let's get the second sample. Sample 2 is going to be get American Pale Ale style beers and get randomly 10 records here. Now we're able to print the sample 1 or sample 2. It returns the data frame, but I just focus on IBU score. That's why here I'm going to return IBU. In that way, sample 1 and sample 2 will return just IBU series. Print the distribution graph for these two samples. Sample 1 dot plot and set its kind argument to KDA. Similarly, do it for the sample 2. Those are the distribution graphs of those two series. They both have the normal distribution. We can also add the label arguments here. Label 1 is going to be the label of the sample 1, and similarly label is going to be label 2. Also title is going to be IB score for both lines. And we forgot to add legend. Let's find the T value first. T value is going to be absolute value of the sample 1. That's mean value minus sample 2's mean value. We are going to divide this value to a square root value, but this requires import math module of Python, and here I'm going to call math.square root, and here let's find the first sample's standard deviation value and find its squared value, then divide it to its size, get its shape, and get its first index value. This is going to return the first term, and we are going to apply same logic for the second series. I mean that here I'm going to call sample 2 dot standard deviation, find its squared value, and divide it to sample 2's shape. As seen, we forgot to add a parenthesis, and let's find the T value. That's 1.63. Now we are going to compare this found T value with a threshold value. Let's find the threshold here. But this requires to import the T table first. You are able to access the T distribution table at this URL. I'm going to share this link in the description of the video. And T table is going to be pandas.read.csv and T distribution.csv. Let's see the content of T table first. Here it mentions a degrees of freedom column, and we are able to find the degrees of freedom for our case, just like that. Find the sample 1's shape and add the value of the sample 2's shape and minus 2, which is 18 in our case. We are going to find the 18 value in this table. Get T tables, degrees of freedom columns. Value is going to be degrees of freedom. Rest of the columns are the confidence interval, and in science we mostly use 0.05. That's why I'm going to get P dash 0.05 column and get its values and 0 index value. This is going to be my threshold. My threshold is 2.1 and my T value is 1.63. Finally, I'm going to compare the T value and threshold, and if the T value is less than the threshold, if this condition is satisfied, there is no statistically significant difference between two samples, and this condition is satisfied. In the else condition, there is statistically significant difference between two samples, but as mentioned, our case satisfies this condition. This means that there is no statistically significant difference between our personal samples and ale samples. So we have mentioned t-test approach in this video. If you enjoyed this video, please like it and do not forget to subscribe to the channel. Thank you for your all support in advance. Thank you all for watching and see you next time.